Pigtailing 12 inches of number 12 or number 10 wire to the number 8 wire at the controller will not make the number 8 wire ineffective for voltage drop. The voltage drop in a wire is determined by the length of the wire, the current flowing through it, and the wire's resistance. The resistance of a wire is determined by its length, cross-sectional area, and material. The cross-sectional area of a wire is proportional to the square of its diameter. In this case, the number 8 wire has a larger cross-sectional area than the number 12 or number 10 wire, so it will have a lower resistance. The lower resistance of the number 8 wire will result in a low voltage drop in the number 12 or number 10 wire. 12 inches of number 12 or number 10 wire will have a negligible effect on the overall voltage drop. The resistance of the number 12 wire is about 0.6 ohms per foot, and the resistance of the number 10 wire is about 0.4 ohms per foot. The resistance of the 12 inches of number 12 or number 10 wire will be about 0.1 ohms. The resistance of the number 8 wire will be about 0.6 ohms per foot. The resistance of the 1000 feet of number 8 wire will be about 0.6 ohms. The voltage drop in the number 8 wire will be about 0.6 ohms times 3 amps equals 1.8 volts. The voltage drop in the 12 inches of number 12 or number 10 wire will be about 0.1 ohms times 3 amps equals 0.3 volts. The total voltage drop will be about 1.8 volts plus 0.3 volts, equaling 1.803 volts. Therefore, pigtailing 12 inches of number 12 or number 10 wire to the number 8 wire at the controller will not make the number 8 wire ineffective for voltage drop. Let's delve a little deeper into the factors affecting voltage drop and how wire gauge plays a critical role. Firstly, consider the fundamental relationship between voltage drop, current, and resistance, as dictated by Ohm's law. Voltage drop is directly proportional to both the current flowing through a conductor and the conductor's resistance. This means that if you double the current or double the resistance, you double the voltage drop. Secondly, the length of the wire is a significant factor. The longer the wire, the greater its resistance, and consequently, the greater the voltage drop. This is because electrons have to travel a longer distance, encountering more obstacles along the way. Thirdly, the cross-sectional area of the wire, which is directly related to its gauge, is inversely proportional to its resistance. A thicker wire, with a larger cross-sectional area, offers less resistance to the flow of current. This is why heavier gauge wires are used for long runs or high current applications. Fourthly, the material of the wire also influences resistance. Copper, for instance, is a better conductor than aluminum and therefore offers less resistance for the same gauge and length. Now, let's consider the specific scenario. You have a 3 amp load that needs to be controlled from 1000 feet away, and you're planning to use number 8 wire for the majority of the run. The question is whether pigtailing a short 12-inch section of number 12 or number 10 wire at the controller will significantly impact the voltage drop. The answer, as previously stated, is no. The reason lies in the relative resistances of the different wire gauges and the short length of the smaller gauge wire. While number 12 and number 10 wire do have higher resistances per foot than number 8 wire, the fact that you're only using 12 inches of it means that the added resistance is minimal. To put it into perspective, let's calculate the resistance of each section. The resistance of 1000 feet of number 8 wire is approximately 0.6 ohms. The resistance of 12 inches or 1 foot of number 12 wire is approximately 0.6 ohms, and the resistance of 12 inches of number 10 wire is approximately 0.4 ohms. As you can see, the resistance of the smaller gauge wire is significantly less than the resistance of the longer run of number 8 wire. When these resistances are added together, the total resistance only increases by a tiny fraction. The voltage drop in the number 8 wire would be 1.8 volts, as previously calculated. The additional voltage drop caused by the 12 inches of number 12 or number 10 wire would be only a few thousandths of a volt, which is negligible in most applications. Now, let's discuss why you might choose to use a smaller gauge wire for pigtailing in the first place. In many cases, it's a matter of convenience. Smaller gauge wires are easier to work with. especially when connecting to terminals or devices that are not designed to accommodate larger gauge wires. For example, a selector switch might have terminals that are too small to accept number 8 wire directly. In this situation, pigtailing a short length of number 12 or number 10 wire allows you to make a secure and reliable connection to the switch without sacrificing significant performance. However, it's important to ensure that the smaller gauge wire is still rated to handle the current. In this case, with a 3 amp load, both number 12 and number 10 wire are more than adequate. Number 12 wire is typically rated for 20 amps, and number 10 wire is typically rated for 30 amps according to the National Electrical Code, or NEC. It's also crucial to make sure that the connections between the different gauge wires are properly made. Use appropriate wire connectors or splicing techniques to ensure a secure and low resistance connection. Loose or poorly made connections can create hotspots, which can lead to voltage drop, overheating, and even fire hazards. In summary, pigtailing a short length of smaller gauge wire to a longer run of larger gauge wire will have a minimal impact on voltage drop, as long as the smaller gauge wire is rated to handle the current and the connections are properly made. The voltage drop is primarily determined by the length and gauge of the main wire run, not by the short pigtail. Always consult the NEC and local electrical codes to ensure that your wiring practices are safe and compliant. It is also a good idea to use a voltage drop calculator. There are many free voltage drop calculators available on the internet, and these calculators can help you determine the appropriate wire gauge for your application. These calculators take into account the length of the wire run, the current flowing through the wire, and the allowable voltage drop. By using a voltage drop calculator, you can ensure that you are using the correct wire gauge for your application and that you will not experience excessive voltage drop. It's also worth noting that in some cases, it may be necessary to upsize the wire gauge to compensate for voltage drop. For example, if you have a very long wire run or a high current load, you may need to use a larger gauge wire than you would otherwise need in order to keep the voltage drop within acceptable limits. The NEC provides guidelines for calculating voltage drop and determining the appropriate wire gauge. In addition to voltage drop, there are other factors to consider when choosing wire gauge, such as ampacity, which is the maximum current that a wire can safely carry. The ampacity of a wire is determined by its gauge, insulation type, and ambient temperature. The NEC provides tables that list the ampacity of different wire gauges and insulation types. It is important to choose a wire gauge that has an ampacity that is greater than or equal to the current that will be flowing through the wire. Overloading a wire can cause it to overheat and potentially start a fire. Another factor to consider is the type of load that the wire will be supplying. Some loads, such as motors, require a larger gauge wire than other loads, such as lights. This is because motors draw a large amount of current when they start up, and this inrush current can cause a significant voltage drop. The NEC provides guidelines for sizing wires for motor loads. When in doubt, it is always best to consult with a qualified electrician to ensure that you are using the correct wire gauge for your application. An electrician can assess your specific needs and recommend the appropriate wire size and wiring methods. They can also perform voltage drop calculations and ensure that your wiring is safe and compliant with all applicable codes. In summary, pigtailing a short length of smaller gauge wire to a longer run of larger gauge wire will have a minimal impact on voltage drop, as long as the smaller gauge wire is rated to handle the current and the connections are properly made. The voltage drop is primarily determined by the length and gauge of the main wire run, not by the short pigtail. However, it is important to consider all factors when choosing wire gauge, including voltage drop, ampacity, and the type of load. Always consult the NEC and local electrical codes to ensure that your wiring practices are safe and compliant, and when in doubt, consult with a qualified electrician. Furthermore, let's explore some practical examples to illustrate how voltage drop can affect different types of electrical equipment. Firstly, consider a long run of wire supplying power to a string of LED lights. If the wire gauge is too small, the voltage drop can cause the lights at the end of the string to be dimmer than the lights at the beginning. This can be particularly noticeable in long runs of low voltage lighting. Secondly, consider a motor that is located a long distance from the power source. If the wire gauge is too small, the voltage drop can cause the motor to start slowly or not at all. This is because the motor needs a certain amount of voltage to overcome its starting torque. Thirdly, consider a sensitive electronic device such as a computer or a medical instrument. If the voltage drop is too great, it can cause the device to malfunction or be damaged. This is because these devices require a stable voltage supply to operate properly. In each of these examples, the voltage drop can have a significant impact on the performance of the electrical equipment. Therefore, it is important to choose the correct wire gauge to minimize voltage drop and ensure that the equipment operates properly. In addition to the examples above, voltage drop can also affect the efficiency of electrical systems. When voltage is lost due to voltage drop, the power company still has to provide that power. However, the lost voltage is converted into heat, which is wasted energy. This wasted energy can increase your electricity bill and contribute to greenhouse gas emissions. Therefore, minimizing voltage drop can not only improve the performance of electrical equipment but also reduce energy consumption and save money. To further elaborate on the topic, let's discuss the different types of wire insulation. The type of insulation used on a wire can affect its opacity and its suitability for different applications. Some common types of wire insulation include THHN, THWN, and UF. THHN insulation is a thermoplastic high heat resistant nylon coated insulation. It is commonly used for general purpose wiring in dry locations. THWN insulation is a thermoplastic heat and water resistant nylon coated insulation. It is commonly used for general purpose wiring in wet or dry locations. UF insulation is an underground feeder cable insulation. It is designed for direct burial applications. The type of insulation you choose will depend on the specific application and the environmental conditions. For example, if you are wiring an outdoor circuit, you will need to use a wire with UF insulation. In addition to the type of insulation, the color of the insulation is also important. The NEC requires that certain colors be used for certain types of wiring. For example, black wire is typically used for hot wires, white wire is typically used for neutral wires, and green wire is typically used for grounding wires. Using the correct colors can help to prevent electrical shock and ensure that your wiring is safe. Finally, let's discuss the importance of using proper wiring techniques. Proper wiring techniques can help to prevent electrical shock, fires, and other hazards. Some important wiring techniques include using the correct wire size, making secure connections, and protecting wires from damage. When making connections, it is important to use the correct type of connector for the application. For example, wire nuts are commonly used to connect two or more wires together. However, wire nuts should not be used to connect aluminum wires to copper wires. This can cause corrosion and create a fire hazard. When protecting wires from damage, it is important to use conduit or other protective measures. Conduit is a metal or plastic tube that is used to enclose and protect wires. Conduit can help to protect wires from physical damage, moisture, and chemicals. In conclusion, choosing the correct wire gauge and using proper wiring techniques are essential for ensuring the safety and reliability of electrical systems. Always consult the NEC and local electrical codes to ensure that your wiring practices are safe and compliant, and when in doubt, consult with a qualified electrician. Remember that electricity can be dangerous, and it is important to take all necessary precautions when working with it. Following these guidelines will help you to create a safe and efficient electrical system.